All right, so here we're going to look at the quadratic formula. And so our previous section, we were doing this process called completing the square, okay? And so what we had to do is we had to come up with a perfect square trinomial and factor that and square root both sides. What the quadratic formula does for you is it basically does all that work for you. So if you were to take this equation right here. So I'm going to, instead of using numbers, I'm going to use variables. So if you had ax squared plus bx plus c equals 0. So where a, b, and c are typically going to be numbers, okay? So if you were to take that and do the completing the square process right now, if you were to, move the c over and then take half of b and square it, it's a proof you can look up on YouTube if you want. It takes about 5 minutes to do the proof. Um, so, anyways, if you do the completing the square process, what happens is you end up with this right here: x equals negative b, or the opposite of b, plus or minus, because see the square root property would be taking place while you're doing the completing the square process, right? So you that's where that plus or minus comes in. The square root of b squared minus, and then there's a 4 times a times c, and then it's all divided by 2a. So all of it's divided by 2a. Common mistake students will make is they accidentally only divide the radical, but you want to make sure the whole thing is divided by 2a. And so that's the quadratic formula. It works out really nicely. And so if it's not factorable, typically this is the method you want to go to. Completing the square is great, and it kind of got us some practice because, like I mentioned in the previous video, completing the square has other purposes besides solving equations. And so that's kind of why you want to get a little practice in this course in case you move on to pre-calculus. Okay, but here we'll go ahead and practice the completing the square process. And it's going to be one of those things where it'll probably take a couple of examples, but once you do a couple of them, it's fairly simple. Okay, so this example they have right here, this example that we're going to do actually works out really nice. It's actually factorable, but I wanted to show you a kind of a simple example to start with. So the first thing you have to do is you have to set it equal to 0. So they subtracted 2x and 1 from both sides, and so that's how you end up with the standard form right here. Then you want to list your A, B, and C value. And so that's the 3, the negative 2. So if it's a minus, you got to take that with it. And then the minus 1 is going to be your C value right there. Then what we do is you substitute all those values into the formula up here. Let me see, make sure we can see that. There we go. So this is a formula that you'll need to try to memorize right here. So negative b plus or minus. So here we have negative negative 2 because my b value already was negative. So I'm going to have double negatives. Then plus or minus the square root of b squared. So that negative 2, you want to put that in parentheses and square it. Then minus 4, which is part of the formula. And then a and c, okay, 3 and negative 1, and then all divided by 2 times a. And then from here, you're just going to simplify it. So the double negatives here cancel out, and that gets us to the positive 2. Then negative 2 squared, that becomes positive 4. And then 4 times 3 times negative 1 is a negative 12. Okay, so then you have a minus a negative 12, which will become plus. So you add that, that becomes 16 down here. Okay, then the square root of 16 is 4. And let me scroll so we can see this. And so you have 2 plus or minus 4 divided by 6. So you can go ahead and simplify that so you look at it both ways. So you do 2 plus 4 over 6, which becomes 6 over 6 equals 1. 2 minus 4, which is negative 2 over 6, and then you want to make sure and simplify. Okay, so those answers actually worked out really nice. That problem was actually factorable. You could have done a factoring process on that to solve that. As we move forward, the answers are going to include radical signs. Okay. So let's go ahead and try some of these. Okay, so here are basically the directions. Write your equation in standard form, which ours already is, so we're good to go. Identify your ABCs, um, and then apply the quadratic formula. So in this particular example, my A is 2, my B is 4, and my C is 1. They happen to all be positive in this particular example. Now I'm going to write down the quadratic formula. I would just write it down every time until you memorize it. It take a couple uh, times just writing it down, but then you'll get the muscle memory on that. All divided by 2 times A. Okay, so now we're going to plug in these values over here. So let's see, we're going to have x equals -4 plus minus the square root of 4 squared minus 4 times 2 times 1, all divided by 2 times 2. All right, I'm going to give myself a little bit more room here. Okay, so I like to kind of work from left to right with this. So let's see. So we still have our -4 right there. Then we have plus or minus the square root. 4 squared is going to be 16. Then 4 times 2 times 1 is going to be 8. And then all over 2 times 2, which is 4. Okay. And don't try to simplify anything until the very end. So you might think, oh, I can cancel out 4s. You don't want to do anything like that too early. Okay, so then now let's see. We have -4 plus or minus the square root of 8 all over 4. Now we can, on most of these examples, you're going to be able to simplify the radical. So that radical, we could break that up into the square root of 4 times the square root of 2. And so that's going to leave us with -4 plus or minus 2 square roots of 2 all over 4. Now all divided by 4. So what we're going to do now is, most of these examples, you'll be able to simplify that 4 with the numerator, but it's all divided by 4. So let's say, for example, what if that 2 was actually a 3? Well, then you really were just kind of stuck. We would just kind of leave it how it is. Now, it's not really a 3, it's actually a 2. And so you look at all three of these and think, do they all have something that they can all reduce by? And they're all reducible by 2. So what you're going to do is you're going to divide all these by 2. So that's going to leave us with -2 plus or minus. That turns into a 1. If you want to put it as a 1, that's fine. Or just write square root of 2, that's fine. And then all divided by 2. And then that's actually your answer. So once you simplify the radical here, if you can break it apart and simplify it a little bit, you're done with that radical. Just leave it there, square root of 2. That's never going to get simplified at that point, okay? So leave that 2 alone. It's not really, it's not the number 2. The square root of 2 is like 1.4 something. It's a decimal. So just kind of leave that alone. But what happened here was all these were divisible by 2. And so that's what I did. And I'll show on this example how you can break it apart and even see it a little bit clearer maybe. So what I could have done is I could have broke it up as -4 over 4 plus or minus 2 square root of 2 over 4. And this answer is going to look a little different, but it actually, it's 100% correct. The computer will take it either way. So -4 over 4 is -1. Then plus or minus, and you can see that this would cancel out right there. And that would leave us with square root of 2 over 2. So this answer is 100% correct also, okay? These two things are the same. They are the same thing. They look a little different, but they are equivalent to each other, okay? If I were to get a common denominator and bring this together, I would have what's in purple right here, okay? So it's up to you. If you kind of like the idea of breaking it into two fractions and simplifying it separately, you can do that. The answer will look a little different, but it's 100% the same, okay? It just looks different. I'm typically going to do it the way I just did the first part. It's less work instead of having to break it apart and do all that. Okay, let's try some more examples. All right, so on number 7 here, I have to set this equal to 0 before I can apply the process. So let's see, we're going to have 2x squared minus 2x minus 1 equals 0. And then let's see, a is 2, b is negative 2, and c is negative 1. So the formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, so now we'll start filling in what we know. So we're going to have negative 2 plus or minus the square root of negative 2 squared minus 4 times 2 times negative 1, all divided by 2 times 2. And like I said, it's kind of just preference. I like to try to work from left to right until I run out of room, and then I'll start working down the page. So the double negatives right here will be a positive 2 now, plus or minus the square root. Negative 2 squared becomes a positive 4. Then I get 4 times 2 times negative 1. So what's going to happen here, so what I do is I leave the negative there for now, and I just focus on multiplying the numbers together. This is another area where students will make a mistake on a sign. So I decide to do it in 2 steps instead of 1. So 4 times 2 times negative 1 is negative 8. And then now I can deal with that double negative in just a second. And then 2 times 2 is 4. Okay, so I have if you want to do this in your head, this will become addition. So I'm going to have 2 plus or minus the square root of 12 all over 4, because the minus 8 actually is, the minus negative 8 becomes plus, so 4 plus 8 is 12. Now 12 can get broken up into the square root of 4 times the square root of 3, right? So what we'll do here is this is going to become 2 plus or minus 2 square root of 3 all divided by 4. Okay, so then now I can simplify the 4 with both of those 2's. They're all divisible by 2. So 2 divided by 2 is 1 plus or minus, that would become a 1 times the square root of 3. So I'm going to put the square root of 3. If you feel comfortable putting that 1, that's fine, but it's not necessary. And there's our answer. And just to be clear, that's the answer to this equation right here. If you were to plug that in for x squared and x right here and simplify the whole problem, it would equal 1. So I don't want to get lost on that these are actual answers, okay? And so if you were to plug those values, 1 plus or 1 minus square root of 3 over 2, it works. And if you want to play around with that later and see that, go for it. All right, let's try another one. All right, so this one right here, I'm gonna go ahead and subtract 10x from both sides, and I want to make sure I keep these in descending order of powers. So the x squared will go first, then I'll put the minus 10x, and then I'll put the plus 18, so I can keep everything in order here. Okay, and then so my a value is understood as 1 in front, my b value is negative 10, and my c value is 18. So once again, we'll go ahead and write down our formula. At this point, you're probably somewhat memorizing it, which is good. Okay, so here we go. So I'm going to have x equals negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 18, all divided by 2 times 1. Okay, double check, everything looks all right. Okay, so let's see, negative 10, that'll become positive 10. Plus minus the square root, negative 10 squared becomes 100. And then I'm going to get minus, and then let's see, 4 times 1 times 18, was that 72, I think? So 72, and then we'll all divide that by 2 right there. Okay, now let's see, we'll have 10 plus or minus the square root. 100 take away 72 is 28, all divided by 2. And then square root of 28, we could break that up into the square root of 4, square root of 7, right? Okay, so then I can go ahead and square root the 4. So we're going to have 10 plus or minus 2 square roots of 7 all over 2. Okay, and then this one's going to actually simplify to where we're not even going to have a fraction any longer. So we divide those all by 2, and so we're going to end up with 5 plus or minus the square root of 7. All right, moving on to our next one. Here we go. All right, so they're using, sometimes we'll use different letters than X. Let's see. So far, yeah, they've been X's. We're using the letter K. Really no different. Just we'll use the letter K instead. All right, so it's already in standard form. So let's see. Our A value is going to be 4, our B value is also 4, and our C value is going to be -1. So if you accidentally put X equals, it's fine, but technically I guess we're supposed to put K equals, and let's see, it's going to be -B plus or minus the square root of B squared minus 4AC, all divided by 2 times A. All right, so we'll start plugging in our values. So -4 plus or minus the square root of 4 squared minus 4 times 4 times -1, all divided by 2 times 4. All right, so let's see, we're going to have -4 plus or minus the square root of 4 squared is 16. And then let's see, 4 times 4 times -1. So I'm going to end up with a minus -16 all over 8. Okay, so we have the double negative, so we're going to end up adding that right there. Okay, so we're going to end up adding that. So we're going to end up with -4 plus or minus the square root of 32, all divided by 8. And then 32, let's see, we can break that up into the square root of 16 times the square root of 2. And so the square root of 16 becomes 4. And then we have square root of 2 still there, all over 8. So that's just the square root of 32 simplified right there. Okay, then we look at our 3 numbers and see if they all have a common divisor, and they do. It's going to be 4. So we want to divide all those by 4. So we end up with -1 plus or minus square root of 2 all over 2. And there we go. That is our answer. Okay, so I have one more slide, and we're going to look at some that are going to deal with the complex numbers, the imaginary numbers. So we'll be square rooting some negative values. Other than that, it's going to be exactly what we're doing here, just that we're going to end up having some i's as part of our answers. Okay, well, here they're using R this time. Okay, so let's see. My A value is 1, my B value is -6, and my C value is 14. So we'll write down our formula. They're, like I said, they're doing R. Okay, so R equals, let's see, -B plus or minus the square root of B squared minus 4AC, all divided by 2A. All right, so it's time to start plugging our stuff in. So let's see, -6 plus or minus the square root of -6 squared minus 4 times 1 times 14, all divided by 2 times 1. All right, so the double negatives will turn into +6, plus minus, let's see, square root, -6 squared is 36. 4 times 1 times 14, was that 56, I believe? So that would be minus 56 all over 2. Okay, so now let's see. 36 minus 56 is negative 20 all over 2. Okay, and so now you can see the really only difference from this problem compared to the ones we were just doing is we have a negative here. Okay, so what I'm going to do is I'm going to pull out the I, and then the square root of 20, I'm going to break that up into the square root of 4, square root of 5. And so that's going to leave us with 6 plus or minus. Now, when I take the square root of 4, that will leave me with a 2, and then I'm going to have my I, and then I'm going to have square root of 5 there. So let's kind of see what happened here. So I had square root of negative 20. So because of the negative, I have to have my I there. And then 20 breaks up into 4 times 5. Square root of 4 is 2. And then the square root of 5 is stuck inside the radical sign. All divisible by 2. And it looks like that will work out here. They're all divisible by 2. So this is going to become 3 plus or minus I square root of 5. And it's not really necessary to put it over 1, so we don't want to do that. So we go ahead and simplify it from a fraction to where now we don't have a fraction. Okay, I think this might be the last. Yeah, this is our last one right here. So to get started, first I'll add 7 to both sides. So that will cancel out. So let's see, we're going to have 4x squared minus 4x plus 7 equals 0. And so let's see, my a is 4, my b is negative 4, and my c is 7. Okay. Hopefully by now we kind of have the formula memorized, so I'm just going to kind of jump in. So x equals negative b, so it's going to be negative 4 plus or minus the square root, and then what goes in here is going to be b squared, so negative 4 squared minus 4 times my a value, so that's where another 4 comes from, and then my c value, which is 7. And then that's all going to be divisible by 2 times a, which in this case is 4. All right, so let's clean this up. This time I think maybe I'll work down the page. Okay, so x equals a double negative, that become positive 4 plus or minus the square root. Negative 4 squared is 16. And then 4 times 7, let's see, let me use my calculator. Okay, 112. And then let's see, divided by 8. All right, so then now I'll work from left to right. So here we go, 4 plus or minus the square root. Let's see, 16 minus 112 is negative 96, all divided by 8. Okay, so negative 96, you know you're going to pull out an I, and then you got to figure out how to break 96 up. And so you might be thinking, oh, 4 times 24. Well, if you break it up into 4 times 24, but then you'll be able to break up 24 into 4 times 6. And that's fine. If you want to do it that way, that's okay. But if you want to do it all at once, you might want to start with your large perfect squares and figure out which one divides evenly into 96. And that's going to be 16. 16 divides into 96 6 times. So if you want to do it in small pieces where you break it apart like 4 and 24, just make sure you break up 24 then, okay? You'll end up with the same result at the end. So let's see where we go from here. So now we're going to have 4 plus or minus 4i. So I got that from right here. And then I'm still going to have square root of 6. And then all divided by 8. Okay. Now, here they are all divisible by 4. So we'll go ahead and do that. So we're going to get 1 plus or minus I square root of 6, all divided by 2. All right, that does it.